Welcome to the course Theory of Mechanisms and Machines. Today's topic, what we are going to discuss is the dimensional synthesis. Under that, we will look into the Grashoff's criteria. At the end of the course, the student should be able to discuss the types of kinematic synthesis for building a mechanism or machine for mobility. According to Grashoff's law for a 4-bar mechanism, the sum of the shortest and longest link lengths should not be greater than the sum of the remaining two links if there is to be continuous relative motion between two links. So, broadly, this has to be remembered as L plus S is less than or equal to P plus Q, wherein we identified that this is L, S, P, Q. That relation should be maintained mathematically. Suppose S is equal to length of the shortest link and L is equal to length of the longest link. P and Q are the lengths of the other links. P and Q are the lengths of the other links. Therefore, the condition that should be satisfied for continuous motion is S plus L or L plus S should be less than or equal to P plus Q if there is to be a continuous motion. So, this is the basic understanding that is being given by Grashoff for making at least one link should have continuous rotation. Note, if S plus S, L is greater than P plus Q, then no continuous relative motion is possible. That is, the above inequality not satisfied. No link will make a complete relative motion to other. So, if L plus S is greater than P plus Q, then this we call it as the type 2 mechanism. Type 2. Okay. If L plus S is equal or less than P plus Q, then we call it as the type 1 mechanism. And other one, what we have to remember is the length of the largest link, say L, should be less than the sum of the other 3 links. Then only it is possible to make any 4-bar mechanism. Otherwise, it is impossible to make any 4-bar linkage mechanism. It is impossible to create any mechanism if largest link is not less than P plus Q plus S. Suppose if you are having the frame as 100, this crank is 20, this is 30 and this is 40. So then we will see that 100 is less than, say, 40 plus 30 plus 20. So 90. So 100 is greater than 90. Therefore, under such dimensions, it is impossible to create any mechanism. Therefore, L plus the longest link should be less than the other 3 links. That is the crux of this. Another interesting aspect of the given Grashoff's 3 criteria he has given, that is the type 1 mechanism wherein L plus S should be less than P plus Q. Type 2 mechanism, L plus S greater than P plus Q, but not L largest link should be less than P plus Q plus S. Then only the formulation of a mechanism kinematic chain is possible. For example, Grashoff's criteria, we can see there will be 4 links, that is the frame, and there is another connecting link 4, and there is another connecting link 3, and there is a hinge. These two are the hinges. Okay, so there is another link, that is the cushioning that is being provided: wall, bar 2, bar 3, and door. So an example for a bar door damper linkage, an example which we have shown there. It is an equal to a 4-bar mechanism. What is a planar 4-bar linkage? 4-link mechanism is the simplest of all closed loop mechanism. Fine. A 4-bar linkage comprises 4 bar-shaped links having 3 moving links, 1 fixed link, and 4 pin joints. Okay. So this is the fixed link, and this we call it as the input link, and this we call it as the coupler link. This is we call it as the output link. So the input link has got, normally it will be shortest link. The output link can have any dimension. The coupler link will have opposite to the frame, transmits force from input to the output. Okay. So a 4-bar chain has 4 turning pairs. This is the simplest of kinematic chain or linkage, in which 4 rigid links are connected by 4 pin joints. Say if you give the numbers 1, 1, 2, 3, 4. Okay. 1 to 2 turning pair. 2 to 3 turning pair. 3 to 4 turning pair. 1 to 4 turning pair. All these are all revolute or turning pairs, we call them as. Okay. So now we have understood the nomenclature. The fixed one, we call it as the frame. The input link can be called as the crank. Output link can be called as the rocker or a lever. Coupler link, which is opposite to the frame, we call it as the coupler link. Then we go crank. A link which can make complete revolutions is known as crank. Rocker. Any link which does not revolve is called rocker. Frame. The fixed link is known as frame. Coupler or connecting rod. Opposite link or of frame is known as connecting rod. Crank rocker mechanism. In a 4-bar linkage, if the shorter link revolves and other one rocks, that is oscillates, it is called as the crank rocker mechanism. Double crank mechanism. In a 4-bar linkage, if both the sides of links revolve, it is called double crank mechanism. Then double rocker mechanism. In a 4-bar linkage, if both of the links rock, it is called double rocker mechanism. So here if you see, the shortest is fixed, then adjacent are L and Q. Then this is called, is the link Q can make complete revolution, full revolution. L also can make complete revolution, and this is called a drag link mechanism, wherein S plus L is not equal to P plus Q, other way around, L plus S is less than P plus Q. Okay, this drag link mechanism is used in the shipyards for dragging the heavy loads in a shipyard. Then comes crank rocker mechanism, wherein adjacent to shortest is fixed. This is the shortest fixed. We can call it as shortest fixed. Adjacent to shortest. If adjacent to shortest is fixed, the shortest can make complete revolution and the link P will oscillate and give the maximum rocking. That is nothing but it will act as a lever. Okay, wherein S becomes crank and P becomes rocker and L becomes the coupler. Okay, so this is called double. This is a crank rocker mechanism. Still, it holds adjacent to shortest is fixed, and still the mechanism holds good. L plus S is less than P plus Q. In the previous one, we have seen crank rocker mechanism in a 4-bar linkage. If the shortest link revolves at the other one rocks, that is oscillates, it is called the crank rocker. Then other one is drag link or the double crank mechanism. Double link or drag link mechanism. Okay. The other one is the double rocker. Opposite to the shortest. This is the shortest. Opposite to the shortest is fixed. Then we are going to get S plus L is greater than P plus Q. No continuous motion. Only the L will make the rocking and P also will make the rocking. So therefore it is called double rocker and no continuous revolution is possible for any link. Okay. Opposite to shortest. Under the condition of L plus S is less than P plus Q, even though this condition is satisfied, opposite to the shortest is fixed, then it forms a double rocker, or S plus L greater than P plus Q, then also all the inversions will lead to double rocker mechanism. Then there is one more mechanism called parallelogram linkage or continuous motion. In this case, the opposite links are equal. Here, these links are this and this are equal. This and this are equal. And this we call it as the locomotive linkage or parallel linkage. In the earlier, when the steam engines were there, this locomotive linkage is being used. So, for example, if you look at it here, this is the locomotive. So, these are the cranks and it can make continuous revolution. There is one more inversion which we can discuss here. Even though if the shortest links are kept adjacent, the connectivity between the linkages is like this. This is equal. So this link is say S units, this link is S units, this link is L units, this link is L units. But still, it can satisfy the condition plus L plus S is equal to P plus Q. This condition is satisfied. So this is a little extension to our parallelogram linkage. And this professor is Grashof. And here we call it as the if S makes one revolution, the L makes half revolution, or if this makes two revolutions, this mechanism will be looking like this. Means for every two revolutions of the shortest link, the longest link will make one revolution. And this is called deltoid linkage. This is called deltoid linkage. So now we have seen how these 4-bar mechanism can be, by changing their orientation of their links, how they can be made as the different mechanisms. Now we go with, already we have discussed this thing. This is the planar 4-bar linkage. Okay. So Grashof's law from a planar 4-bar linkages function. The main function of the mechanism is to produce rotating, oscillating, reciprocating motion from rotation of crank and vice versa. Okay. In the kinematics of the linkage mechanisms, there will be three major parameters that we will have to understand. Here we have identified rotating, oscillating, reciprocating. The linkages have function generation, path generation, motion generation. Okay. The function generation is relative motion between links connected to the frame. We can call this as the function generator. Then path generator, path of a tracer point. We call it as the, if we have got a tracer point, then we can call it as the path of a tracer point. Motion generator, motion of the coupler links. So here in the advanced study, synthesis of the coupler links also will come across. Coupler, synthesis of coupler curves. When you deal with this synthesis of coupler curves, you have to understand about the function generation, path generation, motion generation. Links that can be used, continuous rotation into another rotation motion. The example can be double crank. Then continuous rotation into oscillation or reciprocation. This we can call it as the crank rocker. Continuous rotation into oscillation or reciprocation into reciprocating motion. And this we can call it as the slider crank mechanism. That we will have a small discussion as you progress into the next topics. But this is the double rocker. Then reciprocating motion is a repetitive up and down or back and forth linear motion. For example, reciprocating engines and pumps. Oscillating is the swinging from side to side like pendulum in a clock. Grashoff's law for a planar mechanism 4-bar linkage. A variety of mechanisms can be found created from a 4-bar mechanism through slight variations such as changing the character of a pair. So, from rotation to sliding, proportion of the size, that is the length of the link, many complex mechanisms can be formed from combination of two or more such 4-link mechanisms. Here if you do the changing the character of the pair, means from revolutory or turning pair to a sliding pair. Proportion of the size, if the link sizes are changed, then a different mechanism can be obtained. By changing the character or link length, we can get many type of mechanisms that we call it as the inversions of the mechanisms. Main types of 4-link mechanism, 4-bar mechanisms are double crank, double rocker, crank rocker, as we have discussed. Okay. If you change the character of the mechanism, for example, I will explain you in detail. One, two, three, four. 1, 2, 3, 4. Turning, 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 turning. So all the nature of the 4 links is a turning pair. So we have called this as the 4-bar mechanism. By changing the link lengths and proportions, we can get different complex mechanisms. Another one, what we have told, the changing the character of the pairing element. So I will call this as the 1, 2, 3, 4. This is turning, 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 sliding. sliding or prismatic. So by changing the character, what happened? This also has resulted 1 to 2 turning, 2 to 3 turning, and 3 to 4 turning, 1 to 4 sliding. By changing the character of the 1 to 4 from turning to sliding, the resulting mechanism is called slider crank mechanism, which is applied in IC engines, air compressors, punch presses. Like that, it has got a lot of applications. So main types of four-link mechanisms, we have distinctly classified them into double crank, double rocker, crank rocker. And the other one is by changing the character, you have got a slider crank mechanism. Okay, SCM we call it as slider crank mechanism. And whose applications are there in the real time IC engines? Air compressors. A crank rocker mechanism, in a more detailed understanding, if you see the crank rotates and the other link opposite to the crank rocks from this position to this position as the crank makes a complete revolution. The shortest link can make 360 degrees revolution while the output link moves forward and backward, or it moves from one extreme position to the other extreme position. Okay. Then this is the crank rocker mechanism. This we call it as the double crank mechanism. This is a double crank mechanism. Up the shortest link is fixed, then both the links can make a double crank. That is a double crank mechanism in which the shortest link is the frame. Both input and output links can rotate through 360 degrees, and this is also we call it as the drag link. This is also used for quick return mechanism, because whereas if the first link is having omega 1 as a uniform angular velocity, the other link will have omega 2 is a variable angular velocity. Therefore, the output link will have more acceleration and retardation. So thereby, what is happening? Because the time is the same for taking one complete revolution. That is the reason in certain orientation it moves quickly, in the other orientation it retracts quickly, and this we call it as the quick return mechanism. A drag link can be used as the quick return mechanism. Rocker mechanism, opposite to the shortest, when you make it as a fix, this is called a frame. Then both the links will do the cranking operation, double crank lever or rocker mechanism we call it as. The shortest link can make 360 degree free, but pivoting links can only oscillate. Then Grashoff's law is a very important consideration in designing mechanism driven by motor. Grashoff's criteria used to determine whether or not at least one of the links can rotate in mechanisms driven by motors helps to ensure that the input crank can make a complete revolution. Grashoff's condition is satisfied, then the shortest link can make 360 degrees. Non-Grashoff mechanisms, as the shortest link is moved around, the fact is S plus L is greater than P plus Q means that the shortest link cannot make a complete revolution. The resulting inversions are all double crank mechanisms. So we here, after the further discussion, S plus S is less than P plus Q. This is a type 1, and this is S plus S is greater than P plus Q. This is type 2. Now we can see what are the in inversion of the mechanism. So far we have seen by fixing the different mechanisms, this method of obtaining different mechanisms by fixing different links in a kinematic chain is inversion of the mechanism or inversion of the original mechanism. Beam engine. We have seen how the crank rock lever mechanism acts, but a beam engine is an example wherein the crank makes complete revolution and this is fixed to link 3 and there is a lever. Opposite to this lever, a piston rod is fixed and which can move up and down. Means here the purpose of this mechanism is to convert the rotary motion into reciprocating motion. And this we call it as the beam engine. And this is also a complete revolution of this wheel will make the up and down motion of this particular piston cylinder assembly. So the real time application is a beam engine. Then you can see coupling rod of a locomotive, that is a double crank mechanism, links AD and BC having equal lengths act as cranks are connected to the respective wheels. And these are all these wheels can be railway wheels. And link 1 is fixed and link 1 and 3 are of equal size. And this we call it as the parallelogram linkage or double crank mechanism. The link CD acts as a coupling rod and link AB is fixed in order to maintain a constant center to center distance between this mechanism. This mechanism is meant for transmitting rotary motion from one wheel to the other wheel, which we will use in the railways. Okay? Coupled, uncoupled railways. So, the other wheel is coupled through the link from link AD and CB. Okay. The other one is watt indicator mechanism, double lever mechanism. On any small displacement of the mechanism, the tracing point E at the end of the link CE traces out approximately a straight line mechanism. And this is a double lever mechanism. It is a double lever mechanism. It is an extension of again a 4-bar mechanism. See, indicator plunger and indicating cylinder, and when they move up and down, there will be an oscillating motion will be there from AC and that is being converted to CE. As the piston moves up, the EE dash will make the approximately a straight line. Okay, it is one of the watt indicator mechanism is a double lever mechanism. It is an approximate straight line mechanism. That is what we can understand it. With this, we have tentatively completed a 4-bar mechanism and its inversions, and in the next session we look into the inversion. What is the difference between mechanism and machine, and we will try to understand about the mechanical advantages and its corresponding. The reference books are S.S. Ratan Theory of Machines and J.S. Rao and R.V. Dukkipati Mechanisms and Machines Theory, and these are all the very popular textbooks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.